Unit 3 Chemistry, the combustion of fuels. Now, so before we look in depth at the combustion of fuels, we need to look a little bit at how gases behave, because when we combust fuels, quite often our products are going to be gases, and our reactants are also often gases. So when we are doing stoichiometry, we are going to need to be able to use the volume of a gas to work out what amount in mole we've got, rather than directly using, say, its mass or its density, as we might do for a solution, a solid, or a liquid. So, first of all, thinking about how gases actually behave, because this is key to understanding why we can use the laws we're going to look at. They move rapidly and they move randomly. They move using something called Brownian motion. If we look here, imagine that these are gas particles. Now at the moment we've reduced the temperature in our animation to absolute zero. Okay? So the particles are spread out, but they're not moving at all. If we increase the temperature slightly, we'll see that they're moving in what seems to be a random way. But look at it more closely, follow one particle, and you'll see it moves in a straight line until it hits the side of the container or until it hits one of the other particles. Okay? So they always move in a straight line until we get to the point where they are hitting something and then they bounce off. If we increase the temperature, then they're moving faster and faster and faster, so it's harder to see where they're doing, but they're still moving in this same random way. This is called Brownian motion, and the whole time they were filling the shape of the container, and their kinetic energy was conserved when collisions occur, which means they bang into the side of it, they bang off, they still have the same amount of energy when they bounce off. Okay? So when we talk about kinetic molecular theory, we're saying that gases are composed of tiny little particles, and their volume is much smaller than the volume that the gas occupies. Basically, most of a gas is empty space. They move randomly, straight line motion, they collide with each other and with the container, and those are elastic collisions, which is what we're saying about this kinetic energy being conserved. They have very, very low intermolecular forces. So between one gas particle and another, they're not really attracting each other. And as we saw, when we heat it up, we are increasing the speed of the particles, or their kinetic energy.